Carbon nanotubes are currently mostly only used as bulk nanotubes, which are a collection of disorganized sections of nanotubes. They cannot reach the same strength as individual carbon nanotubes, but are still applicable in many contexts due to their great mechanical, electrical, and thermal statistics, even in bulk. They are currently used in bicycle components, large boats, wind turbines, and sports gear. It is proposed to use single carbon nanotubes, not bulk, as transistors in central processing units or CPUs, which you can find in all computers. As time passes by, transistors have become smaller and smaller, allowing for more to be fit on and therefore efficiency to be improved. But as the germanium that the transistors are made of are becoming smaller and smaller, scaling down to 14 nanometers, they increase in temperature and lose electrical conductivity. Carbon nanotubes are proposed as an alternative material due to their much higher strength and conductivity and lower thermal exertions. Carbon nanotubes pose a much greater model than standard germanium as they are much stronger, 200 times the strength of steel, much more conductive, up to 5 times the conductivity of steel, and exerts much less heat, making it much more ideal for a CPU as the lower the general temperature, the better the performance. When viewed under a microscope, at very high temperatures the germanium frays and crystallizes, however the carbon nanotubes do not. This makes them much more resistant to high temperatures and in effect better at keeping the overall body of the CPU cool. As previously said, carbon nanotubes are a much better solution to CPU transistors than germanium, even down to the elemental level. As germanium heats up, it tends to misshape itself as the particles vibrate more and move out of place. In a CPU, where they may be as small as 14 nanometers thick and another 14 nanometers from another transistor, these slight movements and misshaping may mean the transistor touches another and causes the current to flow in the wrong direction, rendering the processor broken. Carbon nanotubes, however, do not misshape, even under extreme temperatures, making them ideal for extremely small contexts such as this. Hopefully, carbon nanotubes will be adopted soon and will see a great performance and reliability increase in the general market.